Let's discuss the iodine balance, which is both regulated and stimulated by the presence of the thyroid hormones. Now, as we know that iodine is vital to the synthesis of the thyroid hormone. It is actually the iodination of the tyrosine residues on thyroglobulin that produces the thyroxine thyroid hormone. So, the intake of iodine is vital to the process or the synthesis of the thyroid hormones. So, the thyroiodine balance, that is, the amount of intake of iodine and the excretion, and constant maintenance of a single limit or within a single range of iodine in the bloodstream is vital to the both optimal functionality of thyroid, the anterior pituitary thyrotropes, and the hypothalamus. So, iodine must be present in the body, must be circulating in the blood for the thyroid gland to snatch it up, to take it inside the follicles and make the thyroid gland. And the mechanism of the body to maintain the circulating iodine within a narrow range, within the range which is required by the thyroid gland, is what is known as the iodine balance. Now, we take iodine orally. Body has no mechanism through which it can produce iodine because iodine is a micro mineral. Now, the daily intake of iodine ideally should be about 150 micrograms per day. And as it is a micro mineral, it is not synthesized and it is not readily stored inside the body. Even though some part of iodine is stored, large amount of iodine is excreted amount. So the amount of intake and excretion has to be maintained. So the daily intake of iodine, like I said, is 150 micrograms per day and it is taken orally. So once we take it orally through the oral cavity and then into the gastrointestinal tract, it can get absorbed in the gastrointestinal tract at any point. The only difference is the iodine has to be converted into the iodide ion. Once iodine is converted into the iodide ion, it is simply diffused from the lumen of the gastrointestinal tract into the bloodstream. So once iodine is converted into the iodide and it moves through the gastrointestinal tract, that is the stomach and both the small intestine and the large intestine, it can get absorbed into the blood at any stage. But it is usually the small intestine part of the gastrointestinal tract which is mostly occupied with the absorption of the iodide from the lumen into the bloodstream. So, iodine is absorbed into the bloodstream through the gastrointestinal tract. Now, it must be noted that not all of the iodine is absorbed into the body. Some of the iodine is excreted through the fecal matter, and that takes up only about 10 micrograms per day. So, about 5% of daily intake is excreted out, and it has to be excreted out because it balance of the iodine has to be maintained, because only if we get 150 micrograms into the gastrointestinal tract do we get 140 of it into the blood and 10% is excreted out. So once iodide ion diffuses into the blood, it moves into the bloodstream. And when it moves into the bloodstream, first it travels through the portal system or the hepatic portal system. Now, through the hepatic portal system, it gets in touch with the liver or the liver parenchymal cells. Now, in the liver parenchymal cells, like I said, some of the iodine starts to get stored, and it gets stored in the form of either T4 or T3 glucuronides and sulfates. Now, both glucuronides and sulfates are conjugations. They are large molecules which are conjugated with T3 and T4. And once they are conjugated, because of their large size, it is very easy to store both the T3, T4, and the attached iodine. Now, once some of the iodine gets stored in the liver, the circulating amount of the iodine and the amount of the T3 and T4 has to be maintained. And the amount is maintained as the T3 is maintained within a range of 1 to 2 micrograms per liter, while T4 is maintained as 35 to 80 micrograms per liter, while free iodine only takes up to about 2 to 10 micrograms per liter. So you can easily appreciate here that it is actually T4 which is the major contributing factor to the iodine which is circulating through the blood, and it is the T4 which is available in larger quantities to the cell. But once a cell takes up a T4, it is converted into its active form, that is the T3. Now, the reason it travels in T4 or 4 times iodinated tyrosine residue is because the T4 or triiodothyronine, or simply known as thyroxine, is very stable. And because of its stability, it can move around through the whole of the body. And whenever it is needed, it simply diffuses into the plasma membrane, into the cytoplasm towards its receptor. While T3, being the active form, is highly volatile, and it can react with both T4, with other compounds, with free iodine. So that is the reason that T4 moves through the blood in larger amounts. Now, the total iodine content. Now, the total iodine content of the body at any given time must be maintained between 5,000 to 7,000 micrograms. Now, this amount has to be maintained, and this is what is known as the range for the iodine balance. So, all of the oral intake, the excretion, the circulating iodine, both the free T3 and T4, must make up between a range of 5,000 to 7,000 micrograms. And when this range is maintained, iodine balance is achieved. When iodine falls below the 5,000 mark, a person is said to be iodine deficient. And iodine deficiency is one of the leading causes of both hypothyroidism and preventable intellectual disability. Now, because it is both preventable and because it has long lasting effects, iodine is given as supplements and is fortified in foods in almost everywhere. Salt is fortified with potassium chloride, foods are fortified with potassium chloride. The reason being that just giving the iodine can have so much beneficial effect that the intellectual disability or mental retardation gets preventable. Now, it is analogous to the folic acid that is given during pregnancy. That is, only giving folic acid during the pregnancy can reduce the amount or the percentage of congenital anomalies drastically. So, iodine must be given in diet, iodine balance must be maintained, because if it is not maintained, mental retardation can occur because brain development is hindered. And because it is preventable, it should be done. And because of this, supplements and fortified foods with iodine are available everywhere. So, like I said, the iodine balance has to be maintained. So, this range, if it goes above the range of 7,000, urinary excretion starts to happen. And urinary excretion is 150 micrograms per day. Now, you might note that urinary excretion is almost equivalent to the amount of the intake that is required by a human being. And because of this, the amount of intake and output is equal, that iodine balance is narrowly maintained within this narrow range. If it was the other way around, if it is more than 7,000, we get hyperthyroidism, we get Graves' disease. If it is less than 5,000, we get hypothyroidism, mental retardation. So iodine balance has to be maintained. One of the primary reasons is because it is preventable. You do not have to worry about any side effects, you just have to give iodine. Another example would be giving calcium to postmenopausal women. You can avoid osteoporosis in postmenopausal by just giving them calcium. You do not have to worry about the limits or the ratio. Just giving them calcium will prevent osteoporosis in those women.